think we will start with John Haverlack and Nathan with Kepler talking about low Earth orbit.
Okay, Nathan, if you're ready, why don't you go ahead first, and I'll follow. Okay, you might be muted.
Slide, but you're muted.
Sorry, 1 second. Now have we got it?
Got it. Slide, okay. Face, voice, it's all there.
Awesome, excellent. Unfortunately, I'm just the sales and marketing guy, not the technical guy. So apologies for that AV misstep there. By way of introduction, my name's Nathan. As I said, part of the sales and business development team here at Kepler. What I want to do in these quick 10 minutes is provide everyone with a very quick introduction to Kepler, who we are and what we're set out to do, give you a couple highlights from the work that we've done with UAF and the CIWG, and then turn it over to John for some more in-depth details about the actual deployment there. And then I think we're going to have some time for some questions at the end of this as well. So Kepler, we're a relatively small team, incorporated back in 2015. There's currently 84 of us, and we're based in Toronto, Ontario, Canada. We currently have 3 teleports operating around the globe and supporting our first commercial service, which we call Global Data Services, and that's what we have been working with on the CIWG. Just to give you a sense of where we are, so as I mentioned, we're based in Toronto, and in Toronto we have our R&D center, network operations, so command and control of the satellites, and we also design and build our spacecraft, our satellites there as well. And then, as I mentioned, we've got 3 gateways spread around the world to support global data services, one up in Inuvik in the Northwest Territories of Canada, one over in Svalbard, and one over in New Zealand. And then we'll continue to add gateways as necessary to support our customers. And we do have a UK presence and a US presence. The US presence we just opened up, I guess about 2 months ago, and the UK presence, that picture's a little misleading. We actually just have 1 field application specialist over there in the UK. Although we've been incorporated since 2015, 2021 has really been the kickoff for us. We launched 8 satellites back in January, and all those satellites that you see lined up there along the bottom were built in Toronto. And then we followed that quickly by another 2 satellites that we launched in March. And right now we're heading towards our next launch in January. We currently have 15 satellites on orbit, all of them providing services for global data services. And for any Canadians who might be on the call other than myself and Brian, that actually makes us the largest satellite operator in Canada, which is one of our little call outs or claims to fame. I love sharing this picture just because it perfectly encapsulates what CubeSats and low Earth orbit is all about. So on the left there, you see our lead satellite and working on our first satellite that we put into orbit, KIP. And then on the right, you see a traditional GEO satellite, the Intelsat 35. And just to highlight, what does our satellite look like in comparison to a big GEO? Well, as you can see, it's quite a bit smaller. And I think this just does a great job of putting that into pictures. So the first thing that may spring to mind is, does that mean low Earth orbit is, far less capable than GEO? And of course, the answer is no. We've achieved speeds of 200 megabits per second in both directions from our satellites. And that's with a 0.6 meter VSAT, or for those of you who are familiar with Kymeta's U8, we've done that with their ESA. We were the first in LEO to operate in KU band, so we actually beat out the folks at SpaceX and OneWeb. And something else that sets us apart from a lot of the other folks out there in LEO is we've established compatibility with existing mechanically steerable VSATs. So if you're operating a vessel that uses a dish from Cobham like the CTEL or Sailor lines, the Intellian V series, and soon the Aptus NX series, or the Kymeta panels, odds are we can support or work with those, which may save you a bit in terms of upfront capital expenses. And the other thing that I'll throw out there quickly, although this wasn't part of what we've been working with the CIWG on, all our satellites have a software-defined radio, and the most recent Gen 1 generation that we've been launching support both KU wideband for global data services, and we support narrowband or S-band for IoT type applications. Now, we only have 15 satellites on orbit right now, so just to set things straight from the get-go, we aren't a replacement for your traditional SatComms. And what I mean by that is today, our global data services operates in a store and forward manner. So with 15 satellites, you're only going to see those birds a number of times per day. And what we do, why we're above or inside of the user terminal, is we upload or download information from that base, hitting those high speeds that I talked about before, and that gives us the ability to move gigabytes of data per pass. We store that on board the satellite, and then as we come in view of one of our ground stations around the world, we download that information back to the gateway. And then as we add additional satellites to the network, the frequency of the visits increases, and the speed at which we'll be able to download that information back to our teleports and make it accessible on the internet will increase as well. So we typically represent that we're kind of like a Dropbox in the sky or a FedEx overnight service. So for applications where you have large amounts of data that you need to move, and they're not time sensitive and they can stand being delivered in a 12, 24-hour period, then that's the type of application that lends itself well to global data services. And so, as I said, we're not a replacement for the Iridium services that you may be using for voice, or if you're in geo coverage, the services you may be getting elsewhere. But we're a great augmentation to situations where you may be operating outside the bounds of geo, or you might have so much data that you need to move that moving it via geo or via Iridium is just cost prohibitive. And I'll explain a bit more about some of our use cases in just a second. So this is what our user terminal looks like. As I mentioned, if you have an existing VSAT that's KU and is mechanically steerable, talk to us because we may be able to take advantage of that and saving you that additional equipment. And then there's a modem and server that needs to be installed to support global data services. It's odd that we find a modem installed that can support the speeds we can achieve up and down. We are compatible with Comtech CDM 760. So if you have one of those, that's great. We can work with that. If not, we'd have to put one of those in place. And then the server is what we use to handle the store and forward offering. And both of those pieces of equipment, as you can see there, are a 1U rack mount unit. And so, so what is the value of global data services and why would someone want to use a store and forward service? As I mentioned, if you're operating outside of geo, then we're a great shoe-in or a great augmentation there. Or if you're moving large quantities of data, because of our architecture, we're able to move gigabytes of data at around that $20 mark. And certainly that's a ballpark figure in other organizations, and even with CIWG, we've done different pricing. But just to give you a comparison, to move that amount of data with probably the most popular is Inmarsat's fleet broadband solution, it's quite a bit more expensive to go that type of route. So again, if you're moving large quantities of data, odds are we can save you a bit of money there. So in terms of the applications, as John and I were speaking yesterday, and it's definitely a niche application. Like I said, we're focused in operations where you're going to either be outside the bounds of geo, or you're going to be moving so much data that it's just cost prohibitive or impossible. So where we've seen a lot of traction, certainly science applications like the CIWG, seismic and oceanography, hydrography, and oil and gas, all these groups that are generating gigabytes of data per day, and they may be moving that data using SneakerNet, moving physical hard drives around. Those are all operations or situations where we can take that lift and move that amount of data for you. Before we talk about the CIWG, probably our best or most recognized use case thus far, and I think this ties in nicely with the CIWG. For those of you who are familiar with the Mosaic mission that the Alfred Wegener Institute did on the polar stern back in 2019, we supported that. We were able to make use of the CTOW 9711s that they had already installed on that vessel. And for those of you who are familiar, Mosaic, the mission was to go up to the North Pole, freeze into the ice for a year, and then come back at the end of that and share the scientific data. And the original plan was exactly that. And what we were able to do with Global Data Service is help them move that data back ahead of end of mission on a daily basis, so that it would be more useful and accessible to the AWI group in a more timely fashion. And towards the end of the mission, we started sending some big chunks of data to the polar stern to help on the crew welfare side of things as well. And just speaking very quickly about some of the work that we've done with CIWG, one, as John will attest, the CIWG was one of the first maritime operations that we supported while the vessel was underway. So definitely hats off or appreciations to the team on board for going through those teething pains with us. That's a feature and capability that we rolled out while the vessel was underway. And the CIWG was also somewhat unique in that we did install a separate VSAT specifically for global data services, which was the Sailor 600. As I mentioned, that's not typically something that we'd look to do. We're always mindful of real estate on board the vessel, but certainly if there's that requirement there, that's something that we can certainly look to support. So with that, that's kind of the end of my lightning fast overview of Kepler. Happy to answer any questions now or at the end, but otherwise let's turn it over to John and he can dig into some of the specifics around the CIWG's experience with global data services over the past several months.
Yep, thanks, Nathan. Can you stop sharing and then
Yep.
I'll share?
Gotcha.
Okay, can you guys see my screen okay?
Yes.
Yes. Okay, I'll try to move this along. So Nathan covered most of how this works. One thing I just mentioned is that there isn't a full mesh connection of the satellites, so we have to actually send data up to a satellite, wait till it orbits around over the ship, and then it connects to the ship and it shares the stored payload and synchronize it, and vice versa. So bidirectionally coming from the shipper to shore, and not the statistics I'll leave because we've already covered most of that. So our setup looked something like this. So we had a ship side infrastructure. We had Kepler's shoreside was S3, and then we had some shoreside servers on CIWG that patched into that, and a whole lot of voodoo and magic in between. What Kepler gives us access to via the S3 and on the ship side server is a series of directories. And the long short of it is on the ship side outgoing directory, when you send something into the outgoing directory, it moves to the outgoing completed, and then it finally winds up on the shore side incoming completed directory, and then vice versa. So I can dump something in the outgoing directory. So what's important about this is it's basically two unidirectional syncs, one to ship, one to shore. On only files can be synced, so you cannot sync directory structures. It doesn't support nested directory structure levels. So just a single directory gets synced between ship and shore with this directory structure. Okay, so what we did is I wrote a syncer script on top of that would basically translate directory structures into files and then retranslate them back out, recreate the directory structure on the remote side. So it did it bidirectional, and so then I created a little web monitor so I can monitor how many files were pending and what the transfer size that was pending was, so we could kind of keep an idea on the status. Kepler also put together a dashboard web interface for us that showed daily payload being transferred, the tops to ship and the tops to shore and the bottoms to ship. And I'll show you a little bit more about what we actually moved. So we did a 70-day test in 70 days. We moved 105 gigabytes to ship, with an average rate of 119 megabits per second and 226 megabit per second max. I think we maxed out around 8 gigabytes per day one day, but typically around one to 2. And to shore was a lot less. We just weren't sending that payload. There's nothing asynchronous about it. It's just that we didn't have that much data to send to the shore. And how are we doing on time, Brandy? I got about 4 minutes.
Yep.
Okay. So latency, I think our gut feeling is it's about 12 to 24 hours. The metrics data that I started to analyze says 1 to 2. Kind of balking that. However, the to shore was around 10 hours according to the same data. So I need to go back and do further analysis on this. I haven't really, this was just a first pass assessment of it. So there's a lot of stuff missing in here. This only takes into account, this data set here also only takes into account files that were successfully transferred. And so we were moving from shore to ship about 1 to 2 gigabytes a day. We had a max, as I mentioned, and that's about 250 files is what it came out to be. So quick summary, the pros, about $20 per gigabyte, so relatively cost effective compared to other things. Global coverage, about 100 plus megabits per second, call it 12-hour latency, 24-hour latency, and you can move large payloads. The cons are it's a single directory structure, single sync direction, so it's not bidirectional syncing. Integration automation is challenging. End user access is also something we had to integrate ourselves. And our antenna lease was about $20K for the antenna that we leased, but that was also covered by Nathan. Some of the issues we ran into were latency is high for near real-time data. So if you need something within hours, that's one of the problems we ran into with ICE data. We weren't able to get it fast enough. So for our use case, it was challenge. Performance is variable. Vessel tracking was initially problematic because we had to know where the ship was going to be within 100 miles to predict it. But as Nathan mentioned, we kind of worked that issue out and it got automated and that got a lot more stable over time. And so just the overall general visibility of status, they're working on a dashboard and they have new features they're working to add to that. But we need more visibility because everybody wants to know, okay, what's pending. It would be great if there was a way to prioritize data too and say, okay, I want to move this one to the front of the queue and move it first. Potential use cases I see, continuous data syncing to shore, moving data in remote locations, syncing IT updates to ships that it can move the payload, but we still have another part of that problem to solve. Moving videos and other large files back and forth for outreach and such things. So I'll stop there, and that is questions if we got any. We got about 10 seconds.
Yeah, I'm curious. So this is a future with this would be something that's alongside existing network infrastructure for real-time connectivity. And so that's an additional antenna, right, that we're talking about.
It can or can't be. So you can, like as Nathan mentioned, and Nathan jump in if you want, you can leverage existing antennas if they support LEO tracking. And so you can do that. In our case, one of the things that could complicate that is we lease our antennas now from Marlink. So Marlink would have to agree to let us use them for another service. So that could be a problem. We haven't worked that out yet. But so if you have antennas that you can use, you can do that. That's fine. Otherwise, in our case, we didn't want to mess with that because we were just getting stuff set up and we didn't want to have a conflict. So we put a separate antenna on. And because we only have one antenna in the front of the ship, one of the things that could impact our ability and our latency to get things would be mass block, because depending on where the ship's oriented, that antenna might not be able to see the satellite pass for that particular pass.
Right. Interesting. Any other questions?
Any plans for a U.S. ground station?
So at this stage, we're putting our ground stations as far north or as far south as we can, because that's what gives us the most visibility to the satellites in terms of the most frequent passes. But certainly, if there's some other, strategic need, it's very easy for us to spin up another ground station. The one other thing that I'll throw out quickly is, many of the items that John helped us discover over the course of this beta, like the support for a more complex directory structure, user account profiles, and those types of things, those are all on the roadmap at Kepler. And so again, thank you to John and the team on board the CIWG for a lot of this beta testing. A lot of the info and feedback we got is going directly into the roadmap. So hopefully, the next time we do something like this, there'll be new suggestions in terms of improvement, and we'll have crossed a number of those items off the list.
I might just add, so the $20 per gigabyte is the production rate. This was a beta test, so we didn't get charged any data fees. So all the data we moved didn't cost us. The only cost we had was the antenna lease.
How much data did you move? Do you have an idea of how many gigabytes?
I think we said it was around 100 and some gigabytes. Let me pull that slide back up. Around 105 gigabytes over 70 days.
And I saw the U.S. South Pole station go by. Are you currently supporting South Pole?
So at this stage, we don't have an active engagement with USAP. But we are in discussions with a number of academic and scientific and government groups around the world. So hopefully you'll see some different folks on there in the future.
Got it. Yeah, I noticed the New Zealand ground station there.
Yeah, Brandy,
Okay.
I don't think we maxed out our data capacity. So one thing we didn't figure out was how much data can we move per day. Which we moved. This is just what we did.
Right. Well, I appreciate it. That was very interesting. And if folks have further questions, we have the SatCom community topic, and I encourage you to ask some more questions if you have them. But other than that, it looks like our chair has managed to return, Lee.
Yep. After a restart, Zoom was not cooperating. So sorry for the shuffle, but I'm sharing screen now, and we'll get going. There we go. So yeah, I'm going to go through this relatively quickly, so we have plenty of time for Ryan Kaiser, who's next. If I can get, there we go. So this update on the Cyberinfrastructure Working Group. So here's our regular participants for most of this past year. I've got highlighted there Ken, Pam, and Scott. They ran the pilot program, which the contractor was ended up being Peregrine, who many in the fleet have engaged with for your cybersecurity plans and the IMO compliance. So really big thanks to them for taking this on and getting this pilot program started, making it successful. Could not have done it without their support. And I very much appreciate everyone who's contributed to this working group. A little bit about the agencies and frameworks that we're dealing with here. So we have the IMO for the inspected vessels, which is documenting your cyber risk management plan in the SMS. DoD, there was a lot of, as I'll talk about, there was a lot of discussions with Navy about what applies, what doesn't, what's going forward, things are going to look like, and that's DFARS is a contracting term that's in the charters for the ships, for the Navy vessels, and CMMC, the Cybersecurity Maturity Model Certification, that's coming soon to most universities as part of as DoD adopts that. Universities are following suit for the contracts and grants. U.S. Coast Guard agrees with IMO, but there's not any new prescriptive Coast Guard regulation, but we're monitoring those published cyber threats, the strategic cyber outlook, And the National Science Foundation has cybersecurity requirements in a major facilities guide and the requirement for a cyber infrastructure plan. So these are all things we've been working on. These are things that have been feeding into what we do. The program, NSF supported the pilot program for getting the vessels to pass their first inspections where the CRMP was necessary. These will require continual improvement. And I have a slide about what came through this morning from Peregrine. Through this program, the members of the CIWG, we met with Navy, with Rob Sparrock. We individually, we engaged with our contracts and grants office and trying to get an idea. As Rob said at the beginning of RVTEC, he's not a contracting officer, so he can only advise us on to a certain extent. So what we came to the conclusion, there's not widespread CUI at this time. There is some, but it's not widespread. So right now, everyone's in agreement that CMMC level 1 is the best baseline, but that's going to continue to evolve and change. It's just that's where we're at right now. And NSF supports the continued need for a cybersecurity program to address the needs of the ship. So that support has been great for to make this possible. The scope of work was for the vendor to aid each operator. So it's the this was one concern from some stakeholders, which is the universities that accept the terms of what your contracts and your grants are ultimately responsible for cybersecurity compliance. But where these boundaries lie with ships is variable. So aiding operators to get to CRMP in their SMS was key. And this is not just to address the IT on the ship, but operational technology that is expanding on vessels. And the program was able to get the contractor was able to work with each operator for specific needs, and then that they were flexible to meet with ships, to be on site, to help with inventories and things like that. So adaptability was important. A little bit about CMMC level 1. It's the base level of CMMC. It's 17 practices. It's to focused on safeguarding the federal contract information. Rob referred to this in his slides yesterday to RVTEC. And it requires an organization performs the specified practices. So so more on CMMC. There's some registration things that the university should be doing at some point at various points along the way. So more to come on that. It's in the early days of rolling out. A little bit on timeline. So November of last year, the Peregrine contract began, and we started doing vendor presentations in February about what's next. How do we, what do we do if this is the Peregrine was a one year contract for this pilot program to get a baseline of where the ships are. Then we start working with ONR and stakeholders with DFAR 7012, CUI, how widespread is our CUI? What do we need to worry about? And CMMC, how should we incorporate that since we know it's coming? Then we convert the, Ken, Pam, and Scott converted the Peregrine contract to CMMC level 1 instead of this DFAR. It's just based on those discussions. And then in November, the Peregrine contract we're in. And what came out of all this is we have a contract that Scott is working on for ResearchSOC to begin in January. What I want to talk about with some of these policy documents. So these are the policy documents that Peregrine recently sent. These are IMO required policies, and then they send along another 37 optional policies. Me at first glance is how we're going to manage all this. We will get there, but it's a little daunting with the resources we have. But I just want to throw that up there so that we will get there. Next, A brief, I know Brian will talk more about this, but ResearchSOC we're looking forward to that work coming on in January. I'll let Ryan talk more about that. I think that maybe, oh, and this, I just want to go look at a little bit, just a little bit of the statement of work highlights. So these are the key areas. I'm not going to go long on this because Ryan will be talking more about that. I think that's it for me. Any questions?
Yeah, I have one, Lee. We have Ryan coming up to introduce ResearchSOC, but did you touch at all on the choice that we made for ResearchSOC and why we determined that was the choice to move forward with?
I can touch on that. It's so one positive thing about this is that it's being and Jim may be able to chime in more on this. It's being subsidized by another directorate of NSF. So ResearchSOC was created for the what was a proposed program for other large facilities to meet the unique needs of research, large facility cybersecurity. And so it's one NSF large facilities was the first customer of ResearchSOC, and this is being subsidized by NSF in year one. That may not continue. That's not the way it's not going to continue that way. ResearchSOC is going to stand on its own with customers instead of being a wholly funded NSF program with various facilities. But it's but we also thought, I mean, it's the unique needs of research is where we landed after looking at various vendors and what they could provide, what was commercially available.
Yeah, I'll just second what Lee said. Exactly right. We looked at a lot of people. ResearchSOC was a consensus choice. It was a pretty easy choice, and it was helped out by the fact that another director at NSF, the Center for, I can never remember exactly, the Center for Excellent Cyberinfrastructure or something like that. I'm sorry, I'm bad at these things, but it's another huge director in NSF contributed substantially to the first year with the hope that ResearchSOC will make it on their own, and they will if they're good, because we'll continue to work with them.
I will say that we spoke with some folks at UCSD, John Meyer and Kevin Walsh included. We spoke with several program managers at NSF and SICE and some other, and their response was that the academic research fleet needed to articulate what their needs were in order to get more support from other areas of NSF outside of OCE IPS. And so that's what we've been doing. That's what the Trusted CI report was about. That's what the cyber infrastructure working. We need to, as a community, say what we need in order to articulate well what we need in order to get support.
Office of Advanced Cyber Infrastructure. That was it.
Yep.
Toby,
and with that, that's all I have. Yep.
So in the vein of getting everyone on the same page, and at this instance, I'm meaning large governmental organizations like the NSF and NOAA. NOAA has been doing a bunch of, orienting a bunch of their stuff toward the Defense Information Systems Agency, the DISA's STIG's Security Technical Implementation Guide. And we've been looking at that for a while now, but NOAA is pushing for us to become STIG compliant.
Interesting. Yep, there's a lot of change in this area right now. Were there any in the chat? I see some chats. I looked at that. Okay. So I'd like to introduce Ryan Kaiser. He is going to present on behalf of ResearchSOC. He's going to be our POC for the virtual CISO service. So I'll let him take it away here.
Sure. Give me just a second to start my presentation here and share. All right, can everybody see the slide?
Yep, looks good.
All right, probably also see a little bit of the browser tab, but that's just fine. So my name is Ryan Kaiser, like Lee said. I don't have a ton of slides, and I'm going to try to get through them pretty quickly so that you will have a chance to ask me any questions. I'm a senior analyst at the Indiana University Center for Applied Cybersecurity Research. Most of my time is split between two NSF-funded efforts to secure research. The first of these is Trusted CI, through which some of you actually in the audience have already met me before. And I first got the chance to attend RVTEC, I think it was in 2019 during a Trusted CI engagement with the fleet. And the second of these is what I'm going to be talking with you all about today, though, and it's ResearchSOC. So ResearchSOC is a security operations center that is made up of programs and services at 4 different higher ed institutions. And Indiana University provides project leadership, project liaisons, who are the people who are working directly with each of our clients to make sure that they're getting the most out of the services that we provide. RunISAC for threat intelligence, OmniSOC's 24/7 security monitoring. And we also provide what I'm just going to lump into a category of professional cybersecurity staffing services. And these will scale all the way from advisory roles all the way up to full virtual security teams, and sometimes temporary emergency staffing in case there aren't enough personnel available to respond to something like a major security incident. And UC San Diego provides training for higher ed information security to help you understand both how security affects research and also how the research mission itself influences cybersecurity practice at research institutions. And the Pittsburgh Supercomputing Center provides through the Three Rivers Optical Exchange, provides the vulnerability identification service, which we call VIS, to identify vulnerabilities in research infrastructure. It's essentially a vulnerability scanning service that we integrated into our operations. And Duke University provides Stinger, which is a service to deploy and manage honeypots to collect information about things that attackers are actually doing and to provide that information in a way that's practical to use in an operational security. So for example, by making signatures or blocking and alerting. And all of these feed back into our monitoring service as well. And as I alluded to before, we have a strong partnership with Trusted CI. It's the NSF Cybersecurity Center of Excellence. And that close relationship allows for deliberate sharing of best practices and lessons learned from supporting the research community as well as staff expertise. Trusted CI focuses on cybersecurity programs, the community, and building up cybersecurity culture throughout the science community. And ResearchSOC is tightly focused on operational services and cybersecurity operations so that we can be there day to day to help build up the capabilities of our clients' cybersecurity programs and to provide needed resources so that research infrastructure operations like the fleet can focus on research rather than on security. The strategy is pretty simple. We take all those services that I mentioned before, OmniSOC's 24/7 monitoring, the vulnerability identification service, the honeypot service, and the security staffing services, and we bundle them up together in a way that's constantly being updated and tailored to the realities of the research world. And I'd like to take some time to talk a little bit about OmniSOC 2. OmniSOC is a shared cybersecurity operations center for education and research networks pioneered by 5 members of the Big Ten Academic Alliance. And our platform engineering team manages and supports our security analytics. So they're working sort of day in and day out to make solutions that will help our analysts and engineers to make sense of all the security data that's coming in from all the different sources that the member institutions and our clients are actually providing. And our security engineering team monitors and analyzes our member institutions' networks and endpoint activity for anomalies and threats using all of that data. So because all this data is provided to them across all these member institutions, if an alert shows up for one member institution, they can take that data and then start to look for those patterns to find threats at other institutions as well. So it's allowing you to search for threats across all of the members. I'm looking at this now, and this slide is a little bit old, so those numbers might actually be higher now. And we're relying pretty heavily on the open source tools that make up the Elastic-SAC, and Elastic is a key technology partner for us. And we've earned ourselves some superlatives as well. I'll brag about a few of these. So like the last one, this is an old slide, but to my knowledge, these statements are all still true. We are the only collaborative multi-state SOC operated for and by academic institutions. We're the only collaborative SOC serving NSF research facilities, and we're the only SOC with a multi-state institutional data sharing agreement for researchers. And I'm still confident that we have the top higher ed threat hunting team in the country. So from the beginning, we intended to provide our core services that I talked about already. And I think these are even more capable today. So security operations center services to NSF major facilities, providing honeypots and vulnerability scanning, and providing personalized support to each facility to closely integrate with their operations so that our services are as directly applicable to the operation as they can be. And also, since we started, we've been improving our services and extending what we can do, and we intend to continue to do so. So that might be by adding new services or working with researchers to analyze our data and to generate some practical improvements for us and for our clients. And we're always looking for ways to get better. So the overview out of the way, and with a caveat that this is still in contracting and thus technically still subject to change. These are what we're looking to provide for the fleet. So we've got staff, services, and some security infrastructure as well. In year one, we're going to be working to get the basics in place and take on activities that help us to understand how to best serve the fleet. That means basic monitoring and security services, as well as tailoring programmatic fundamentals to meet the needs of the fleet and building on work done during the pilot project that Lee discussed. It also means experimenting with some security architecture by doing things like testing different locations for security monitoring appliances. And in turn, in year two, we intend to build on what we learned in year one in order to both improve the support for ship operations and to build up the security of the ship networks themselves, if we can. And so that was me very quickly running through these slides. Thank you for taking the time to listen to me. Our website is up there. You can contact us at research or rsoc@iu.edu. And that's all I have for the basic overview. I know it's really brief, but I want to stop here and leave as much room for questions as possible. And in advance, I want to apologize if this is the case, but if we can't get to something in time, you can always reach out to me directly using the email address that is on screen right now. So I'll stop here for questions.
Yeah, thank you very much, Ryan, for taking the time to present today. And I know the contract is still going forward, but we're looking forward to getting this going. Are there questions? Do we have questions for Ryan, or in general questions about ResearchSOC? Go ahead, Kenny.
Yeah, so you're collecting all this data on the threat actors that are being presented to academia. How much is that like cyber criminals versus state actors versus just kind of, script kiddie type stuff?
I'd say it probably depends mostly on what you have. Vague generalities, most of it is just going to be automated scanning and script kiddies, because those are the most common type of attacker because they require the least amount of expertise, and they tend to be pretty indiscriminate. That said, there have been instances that I know of people targeting research infrastructure, oceanographic research infrastructure as well, that are from nation state actors. Yeah, so you'll get a bit of everything.
Thank you.
And the current topic on everyone's mind is obviously ransomware. That's been around for almost as long as I've been on the earth, but it's now really, really prevalent. And that's mostly criminal gangs.
Has there been an increase in sophistication of that type of stuff, or just more of it out there?
Both. It's much more sophisticated, and it will continue to get more sophisticated just because the profit motive is there.
Yes. Oh, go ahead and let John. John, go ahead and go first, and then I had something.
Yeah, Ryan, could you just maybe touch bases on the program that we're looking to develop for the fleet, how it may or may not be compatible with university efforts or other external compliance efforts that we have?
I might ask for a little bit more clarification on the question, but I can speak generally, but I might not answer what you're open for.
One of the things would be like what efforts we do with ResearchSOC, how do those align with CMMC for our institutions? And or like the question that Toby just asked about, I think NOAA has a compliance restriction. How does this help us? Does it muddy the waters? What is your perspective on that?
Yeah, so it's, in my view, and I think I can speak generally about ResearchSOC, we believe that the right approach to take for cybersecurity programs is the Trusted CI framework for research cyber infrastructure. And within the framework, you'll find plenty of room to address regulatory requirements like that for CMMC in very different ways. And it's primarily because there's such a variety of different requirements. And I think the academic research fleet might be an example of one that has a particularly wide range of requirements compared to other research infrastructure operations. So my objective would be to get us going down that path of implementing the framework. And a huge part of that is going to be your regulatory requirements.
Yep. Through some of the mailing lists I'm on at UCSD, I've seen some of the ResearchSOC, some of your presentations, some other presentations. Is there something we should consider for folks that may want to opt in and learn more about some of the initiatives that are out there?
Yeah, so we do have a webinar series. That might be what you're referring to. I can dig up the link to that right now and just send it in the chat.
I think that's what it was. Yep, I just kind of stumbled across it through some mailing lists.
Yeah, you can find it on our website. That's what I'm actually going to do right now. Okay, so yeah, researchsoc.iu.edu/training. Let me just drop that link directly into the Zoom chat.
So I think some of those had some good topics for folks. They may not be directly for activities at sea right now, but these are the things. Yeah, I think but some of them were relevant to
yeah. And there's also all of the, like Trusted CI does webinars as well, and Trusted CI also offers trainings on top of that. So both of us often end up collaborating on a lot of these things.
Yep.
So for the future meetings, would you rather go by Ryan or Cecil?
Definitely Ryan.
One of the things that I hear sometimes is why is cybersecurity important to the research fleet? Because the data is all public and we're not trying to keep the data under lock and key. So what's the risk? Would you mind touching on that a little bit and not into the details clearly, but broadly, why it's not just about our publicly funded data.
Right. Yeah. So this is actually something that's different about research infrastructure just broadly. And Trusted CI has been kind of wrestling with this question for a long, long time, and actually has very good answers for it. So I'll defer to that answer, which is that in the research world, we tend to focus not on confidentiality, which is what we're used to in cybersecurity practice in every other domain that I'm familiar with. But rather than confidentiality, we're focused on integrity. We're focused on things like, do we trust the results that we're getting from our scientific instruments? Do we trust the integrity of the data that we collected before? Are we able to go back and reproduce our results from before? And if somebody can tamper with those in ways that are hard to notice or hard for us to realize, they can change our perceptions of the world in unsettling ways. So, and they can also reduce the trust in the research that we are doing ourselves and our own research infrastructure operations too. Does that answer the question?
Yeah, that's an excellent answer. Anybody else have questions?
Yeah.
I had one more comment. I mean, we presented to the presentation today about expanding bandwidth. I mean, one thing we've been concerned about here is as we expand bandwidth on the ships, that makes us a bigger target. Before, the link was too slow, but if we have more bandwidth, it could have more issues.
Yeah, and so the thing that people have often heard of is the CIA triad: the confidentiality, integrity, and availability, and that you're trying to balance between those three characteristics. Personally, I think there are more than just those three, but I think that idea that you're always balancing your efforts between some limited set of characteristics is really apt. And I just think that in most other places, say in finance, for example, you're highly concerned about the confidentiality, but you're probably pretty concerned about, say, integrity as well. And for some systems, you might not care as much about availability, so you just prioritize those two, or you prioritize confidentiality. But it's a little uncommon outside of the research world to have your primary focus not be on confidentiality.
Great. Thank you very much for all the answers and for presenting. We can continue questions in the community tab there. Any discussions anyone comes up with through the remaining course of the meeting. I think we'll be wrapping up this session now. And next, we have the poster session. Is the live poster session? That's it.
So Finn Moore at McGregor is doing a live presentation for McGregor's poster this afternoon. Tomorrow afternoon, Rebecca Hudak, I hope I said that right, will be presenting on transmissometer best practices. There might be another one that pops up. So it would be a good idea to go and browse the poster sessions today. And we have a lot of MacGyver entries now. So take a look at those and we'll get a survey put together for that. But otherwise, we'll see the rest of you tomorrow morning. And we look forward to seeing more of Ryan at all of our future RVTECs.
Yeah, hopefully we can be in person.
Yep, that's what we're looking forward to as well.
Now you have to learn everybody's name.
Oh, I remember you, Jules.
You were in Alaska, right, Ryan?
Yes, I was. That was Fairbanks.
Yep.
Yeah, that was a great time. I really enjoyed it.
It was a great meeting. That was the last live